Okay, so I want to do an example of finding inverses that's a little bit different than some of the others we've talked about. So here's a function. F of x is 3x over 2x plus 3. Okay, so how do you usually try to find inverses? Like, what's the procedure I've given you guys today for finding inverses? Yeah, you might try to solve, right? And then write down the steps for solving. There's going to be some weirdness here. How do you solve this thing?
Don't you multiply by 1 over 2x plus 3 to get to 3x plus 1?
Yeah, you need to kind of put the x's on the other side and then like subtract over or something weird.
Yeah.
You guys see that doesn't really fit nicely into a bubble diagram? Like normally what I'm doing is I'm thinking, okay, what do I do to x first? Right?
Yeah.
But this one has sort of two, like, well, you put x in both those spots, and in one of them you multiply by 3, and in the other one you multiply by 2, and that doesn't really fit conveniently into this picture. You guys see that? Okay, so let me give you another, I'm going to give you another procedure. I don't particularly like this procedure, and there's a way to do this with bubble diagrams anyway, so I'm going to show you both. Cool?
Mm-hmm.
So here's your other procedure, and this is one you'll find in books and lots of places. So you say, all right, y is 2x plus 3, right? This is an output.
Yeah.
Okay, and then you do your level best to solve for x. Okay, so now we're going to do what, I'm not even going to try today, what Bob suggested. So we're going to multiply by 2x plus 3, right? So what do you get on somewhere?
6x plus 9.
No.
Yeah, 6x squared.
2x plus 3.
2xy.
So you have y times 2x plus 3.
Oh, I see. I was already on the other side.
Right? And then on the other side, they cancel, which was the point.
Yeah.
So you get 3x. Okay, then I think you distribute, right? On the left-hand side.
2xy plus 3.
So you get 2xy plus 3y is 3x. Then what?
Divide by 3.
No.
Oh.
No.
No, you want to get the x's to one side.
You want to get the x's together and the other shit to the other side, right?
By
So
x.
then you subtract.
So I think I need to
Oh, you can't divide by x.
maybe
Subtract.
subtract 3x and subtract 3y.
Wait, what?
Yes. I want the x's together and the y's on the other side.
Yeah.
So I'm getting the x's on one side and everything else to the other.
Couldn't you?
But you have a y with the x.
Yeah, I got a y tangled in there, so I'm going to have to get that out. So I got 2xy minus 3x is
Negative 3y.
negative 3y. Okay. Then what?
Divide by y.
No.
Because you can't.
Yeah, if I divide by y, I'm going to end up with an over y in this piece.
Factor out an x on the left-hand side.
Good.
Isolate x, yeah.
Good. I need to isolate x. So I'm going to factor x out left-hand side, right? So by factoring x out on the left-hand side, I'm going to have x times
2y minus
2y minus 3, and that's equal to minus 3y.
Oh, you just don't want to take this answer.
Divide it.
Okay.
And then we're going to divide by 2y minus 3. You guys all see that?
Yeah.
Okay, so I'm going to get x is minus 3y over 2y minus 3.
That's so pretty.
Okay, so where's my inverse function?
Right there.
Yeah, so my inverse function then would be f inverse of x is minus 3x over 2x minus 3. You guys see I pulled a fast one and switched the x's and y's?
Oh, that's tricky.
What's going on there?
Pull the fast one.
Use the inverse of f of x, not.
Yeah, so that's this picture, right? I had a blob, I was doing F to it, right? So I had X's over here and Y's over there.
You did what the book did.
Yeah, but then I want to phrase I want to call this F inverse, but I don't want to have it of Y, I want to do it of X. So I swapped X and Y. Yeah, because it's an inverse, so its inputs are the old outputs and its outputs are the
New input.
old outputs.
Wait, so in other words, are you trying to find the inverse of f by going to y and then applying that to x to begin with to go even farther to the left so to get everything?
I'm just renaming everything. So
He's just
there,
being complicated.
right? This black bit was X's are over here, Y's are over there.
Mhm.
And then I'm just going to say, okay, when I move to the inverse function, I want my functions to be functions of X.
Mhm.
And that means I need to,
Have that be one.
yeah.
Okay.
So I'm just going to switch the
Okay, I see.
Y's to X's.
That makes sense.
You guys okay with that?
Yeah,
You want to see the bubble diagram way to do this one?
not really.
You can actually do it.
I like this.
So this way is totally fine. The thing you have to be careful of is lots of you guys have in your solving like step repertoire things that aren't functions. Like you guys know how to solve things with those inverse tangent functions, right? But we cut their domains, so there's all sorts of weird crap going on there, so you'd have to account for more than one value, and then the inverse function doesn't exist. You guys see that? If we went through this stuff and we had an x squared, right? We'd maybe take the square root of both sides. That's not a function, right? So my inverse function's just not going to exist. You guys see that? You have to be careful when you're doing this solve process because you might run across one of those things that's not an inverse function. Cool?
So when we run across it, we just stop.
Yeah, if you run across one that you can't get around some other way, yeah, you can stop and say there is no inverse. You guys see that?
But what are those? Did we go over those earlier last week of what not or
Yeah, things you're
cannot-
not allowed to do.
Yeah, the
Yeah.
square roots and everything. And
Yeah, things you're not allowed to do are functions that you don't know how to invert functions that fail the horizontal line test
okay.
without doing a little bit of rigmarole, and it's that rigmarole that you should be scared of here. You guys want to see the bubble diagram for this thing?
Yeah.
That function has an asymptote.
Yeah, this function has an asymptote, which is what makes inverting it a little bit tricky.
X cannot equal.
So if we want to try the bubble diagram, we just think about this.
How can we get the denominator to zero?
Yeah, so I want to make this thing into a more convenient form, right? So I could take 2x plus 3 and try dividing it into 3x. You guys see that? So if I try dividing this in there, let's see, I get 2x goes into 3x. Yeah, inconvenient times. 2/3 of a time. You guys see that?
Yeah.
If I multiply not 2/3, 3/2 of a time. If I multiply 3/2 by 2x plus 3, I get 3x plus 9/2. Right? Then I want to subtract this crap off. You guys remember this algorithm? So I get 9/2 here, minus 9/2. Yes? Okay, so I got 3/2 minus 9/2 divided by 2x plus 3. So I can rewrite this function as 3/2 minus 9 over 2 over 2x plus 3.
Yeah, actually that'd be a bit better.
Right, and now there's 1x. So I could bubble diagram this thing. So the bubble diagram for this guy is going to be really inconvenient because the numbers are horrible. But you start with an x, what's the first thing you do to it? Multiply by 2. What's the next thing? Add 3. What's the next thing? Put it on the bottom of a fraction, right?
So negative exponent.
So 1 over x it, or 1 over stuff it. Then what do you do?
Multiply
Multiply by 9 halves. Okay. You guys, did I lose you back here?
Can you
Samia?
show us what that would look like?
Yeah, so I started with an x, right?
Mhm.
So then I multiplied by 2, so I was rocking 2x. I added 3, so I had 2x plus 3. Then I needed right? I need 2x plus 3, but on the bottom.
Oh,
So I'm going to put it under a 1. So now I'm going to be looking at 1 over 2x plus 3. Then I need a 9 halves on top.
these multiplies.
So I'm just going to multiply by 9 halves. And that's going to get me to 9 halves over 2x plus 3.
Don't you multiply fractions together? Don't you have to combine the bottom terms and the top terms so that what you get?
Yes.
It's the same, yeah.
Yeah, you might ask yourself, could I have done better, right? Could I have simplified this a little bit up here? And I definitely could have. That would make my life easier. I don't know why I tried to do
That's
it.
just
but-
visually.
Then what? What's your next thing?
Add 3
No,
over 2.
negative.
Yeah, you want to make it negative, so you need to multiply by negative 1. Now I got negative 9 over 2 over 2x plus 3.
And now add.
And now I need to add 3 halves to it. So, to get out of this,
You do those things backwards.
yeah,
And oppositely.
do these operations, right? I need to do the inverse operations in the opposite order. So I subtract 3 halves. What's the opposite of multiply by negative 1? Yeah, multiply by negative 1. Or divide by negative 1, right? Those are the same thing. It's the opposite of multiply by 9 halves.
Divide.
Yeah, divide by 9 halves or multiply by 2 ninths. What's the opposite of 1 over stuff?
Stuff over 1.
Mm-mm.
Times
If you flip a fraction over, how do you get it back?
Inverse.
Times by the.
Just flip it over again. Okay, see that? Okay, how about the opposite of adding 3 is
Subtract.
subtract 3, and the opposite of multiply by 2 is
Divide by 2.
divide by 2 or multiply by a half.
For the 1 over something, wouldn't it make more sense to, for the inverse to be multiplying by whatever step is below 1?
Oh, you're dividing by stuff versus he's saying multiplying by stuff.
Yeah, so here I'm really doing the function 1 over x here, right? Or 1 over y or whatever.
Yeah.
So think about that as reciprocating a fraction,
Okay, yeah, 'cause it's like.
right? So if you're reciprocating a fraction, the way to get it back is to reciprocate again. All right, so if I wrote down a formula for this business, right? This would give me f inverse of x is, oh God. So I start with an x, right? I subtract 3 halves. Then I multiply the whole thing by negative 1. Then I multiply by 2 over 9. I can multiply by negative 2 over 9. Then I need to flip the whole thing over. So I put a 1 over the top of all that crap. Then I need to subtract 3 and multiply the whole thing by a half.
That's awful.
Yeah, so this got kind of nasty, right? You guys see that?
Yeah.
So is the bubble diagram a nice thing to have? Yeah, for sure. Is it nice on this problem? Hell no. Right? So sometimes it pays to have that other trick up your sleeve. Just be careful with it when you're solving. If you do a solving step that should have a like plus or minus or more than one answer, you need to stop and say there isn't an inverse function. Cool.
Mhm.
That really amounts to one of these arrows, right? That's a function that doesn't have an undoing. Cool.